We were looking at this numerical problem from the goods market model. In part A, we determined the equilibrium values. In part B, we verified the goods market equilibrium condition. And in part C, now you want to graphically depict the goods market equilibrium. Now, the idea is this, that graphically, goods market equilibrium is given at intersection of the 45-degree line, which is the z is equal to y line, and the demand schedule C. Right, so we know the 45-degree line is just essentially an upward sloping line with slope is equal to 1 that passes through the origin. Right, and now for the demand schedule, right, because these are the two elements of our graph. Now for graph of z against y. So we want to plot z against y. Now this is going to be our y-axis variable that we plot on a vertical axis, and this will be a horizontal axis variable that we plot on our x-axis. So for this, recall general equation of straight line. It's y is equal to mx plus c. Now this y corresponds to z because that's a variable we plot on our x-axis, and this is something we found in part A. So this is like the demand function that we found in part A. So let's now compare these, right? That the y, like in the general equation of straight line, the y variable now, which we plot on the vertical axis is z. This is what goes on the y-axis. Right, we know m represents slope, which is the value 0.6 here. So this represents our slope. Right, there are a couple of things to note here. Okay, the slope is greater than 0, so it's upward sloping. And slope is less than 1, so flatter than 45-degree line. Right, which has slope equal to 1 like we discussed. So there are two things when we're plotting the demand function. We know its slope is positive, so it's upward sloping, and its slope is less than 1, so it's flatter than the 45-degree line. And C over here corresponds to 340, which is our y-intercept value. This is our vertical intercept, which represents autonomous bending, right? And this demand function is actually from part A. So vertical intercept, and this represents autonomous bending. Right, so in this way, we are seeing how will we plot this, right? We'll plot a 45-degree line, which is an upward sloping line with slope 1 that goes through the origin. Then when you want to plot our demand schedule, then we know, okay, this we have z is equal to 0.65 plus 340. We found this from part A. Here we know the slope tells us it's going to be upward sloping and it's going to be flatter than the 45-degree line, and it's actually quickly plotted. So if we want to plot this, so this is our vertical axis, this is our horizontal axis. Now I'll plot the 45-degree line as an upward sloping straight line that goes through the origin with slope 1. And I plot my demand schedule as upward sloping and flatter than the 45-degree line. Right? Let me just erase this. Okay, so this we know is our y-axis, which represents demand z. We know this is our x-axis, which represents output or income y. right? And this is our 45-degree line, right? And we know this has the slope 1, right? And then this we know is our demand schedule. Z is equal to 0.65 plus 340. We know this has the slope 0.6 when we compare it to the general equation of straight line, because this was a linear function, so this is how we could plot it. And we know its vertical intercept is 340 given to over here when you compare it to y is equal to mx plus c, and this represents autonomous bending. Right, and we know, okay, goods market equilibrium occurs at the point of intersection of the 45-degree line and the demand schedule. So this is goods market equilibrium, which we know is where z is equal to y, right? This is the goods market equilibrium condition where demand is equal to output or income. So this is the goods market equilibrium at intersection. Graphically, it's at the intersection of the 45-degree line and the demand schedule. Right, and we know this gives us equilibrium output, and this we found in part A already. Okay, y star is 850. Right, so this is our equilibrium output. And since we know in equilibrium, demand, which is on vertical axis, is equal to output or income, which is on horizontal axis. So in equilibrium, if y is equal to y star is 850, then z is also equal to y star is equal to 850, right? So we can represent the equilibrium output on the vertical axis also, because in equilibrium, demand, which is on vertical axis, is equal to output, which is on horizontal axis.